Welcome to your storm chasing forecast show for Saturday, July 18th. I am Gabriel Harbor. He is Cameron Nixon, and you folks are going to get all the smoke discussion this evening. What's going on,
Yes.
Cameron?
Not too much. How are you good?
I'm doing all right, man. I've been fighting the good fight over here, not going outside today because I'm in central Ohio, and I woke up
Yeah.
to a bevy of notifications on my mobile device telling me basically stay indoors or you're going to
Don't
smoke
go
like
outside.
3 cartons of Marlboros, and I didn't want to do that.
I saw Matthew Capucci's comment that it's like plastic smelling, like, oh my God. Miss me with that.
Yeah,
Did
and
it smell
it
for you?
I didn't actually go outside at all, not a single time today. So
Good
I
for
just
you.
stayed
Okay.
indoors. I probably would have done that anyways, full disclosure, even if there wasn't any sort of smoke outside.
Yeah, yeah, fair.
But I did look outside on a couple of occasions, and I also saw some pictures from people who live around the area, and there's this really weird orangish, yellowish haze, especially when the sun was high in
Are you
the
sure that
noon
wasn't just
sky.
the enhanced risk?
Wouldn't that be funny if in the future they're actually able to create like holographic projections of the contours for the
I'm sure the
categoricals?
conspiracy theorists would
That
not
would be
mind that at
incredible.
all.
So you wake up and you have like yellow like casting a reflection in your window, and you know you're in a slight risk for the day.
That's 1984.
All right. Jokes aside, Cameron, I did want to talk a little bit about that smoke and how it can affect severe weather. I know that
Yeah,
in the SPC Outlook, they actually did mention the clearing up of the smoke as being something that could actually aid in the diurnal heating, I think, if I read that
yeah,
correctly. So
I
if you
saw
could maybe
that.
give a crash course, that would be awesome.
There you go. Her-based forecasts suggest that smoke will become less prominent from west to east by afternoon, which should allow for relatively strong diurnal heating. So yeah, you're completely right about that. As we saw a few days ago, there were some storms, and I think it was the northeast that were formed along this kind of differential heating boundary between smoke and non-smoke. And obviously, we know that if we're relying on peak daytime heating, kind of open warm sector stuff, smoke can absolutely meddle with that. You're literally turning off solar radiation. And for people who know modeling, once you turn off solar radiation, you don't get convection. However, I think there's going to be a lot fewer failure modes today because we're dealing with a lot more broad scale synoptic forcing for ascent. And so I don't think we're going to have to rely on daytime heating to get storms.
Excellent explanation. And before we dive into it, start from the top at 500 millibars, I would like to
Yes.
let all of our viewers know that we do have a new 2027 Storm Chasing Tour that just opened up.
Mm,
The demand on the previous one was absolutely insane. It sold out super quick. So after some lengthy discussions, we decided we would open up one more. The seats are going to go fast. The link will be down in the description. It's 7 full days of storm chasing, hotels paid for, the fuel, of course, and the vehicle provided. So if you want an opportunity of a lifetime, check that out. Link in the description below. Let's go ahead and take it from the top at 500 millibars. Very interesting, again, that we have some northwest flow that is, I don't know if it's exactly, but it's most maybe orthogonal to the boundary. I don't know. You let me know.
yeah,
You're the
oh, it is.
expert.
Yes, no, definitely a large degree of orthogonality, if that's a word. Still dealing with our kind of broad troughing from yesterday. That's going to shift into the area. And what's interesting is you could see a really rapid, I guess, entrance of a jet behind this trough too, basically phasing with this lead trough here. And when you get that jet phasing, and especially when you get these really fast jet translation speeds, this is a Chris Broyles special, you tend to get some pretty significant severe weather. So it's not really a surprise that we're outlooked for an enhanced over most of this area. So if we go down a little bit more, you could see our 700 millibar pattern. We see this remnant wave that we were dealing with yesterday still coherently making its way in here. A little bit less phasing in 700 millibars. You can still see that just one singular wave here. But something I also noticed is you can see another wave developing out in front of it. So that might be influential too. And I apologize if y'all hear fireworks or firecrackers outside my window. I think we're still dealing with some remnant 4th of July celebrations too. But insert pun about
I was gonna say, I love how you
that.
phrase that remnant 4th of July celebrations. So.
I'm in remnant NCV mode. But yeah, and so that low pressure center that we were tracking yesterday is going to progress and deepen as these jets merge over the northeast. And so this is kind of going to be our main driver for a cold front to the south. You can see that here coming in, probably also much drier air. But you can also see out ahead of this, just to the lee of the Appalachians, you can see some strong heating. And this is called compressional heating, when you have strong flow going over the mountains and then immediately crashing down to the surface. You can get some much warmer temperatures in the lee of the Appalachians. So I think this low pressure center here might have something to do with more convection out ahead of that cold front. So really kind of messy, bimodal, at least, ways to get convection.
So I have heard a little bit about that Broyles research on the translation speed of the 500 millibar jet.
Yes.
Could you maybe
Yeah.
share a little bit about the mechanism that actually sets that into motion and maybe what it actually affects as far as storms maybe being a little more severe than you might have otherwise expected?
I don't know.
Hey, fair enough.
I think I'm going to give you as firm of an answer as that as I can. I think this is one of the most fascinating questions in severe research right now. Chris just kind of mic dropped this relationship, and we still have no idea why it's potentially a thing. I've chatted with a few folks. It might intimately play into how the forcing mechanisms are structured, maybe what the dry punch behind the system looks like, maybe even it's just the process of strengthening the wind fields over time that allows supercells to be more robust and or long lasting. Could be any number of things, and we have no idea.
That's super exciting, actually, because
I agree.
when you oftentimes think of science in the year 2026, you think a lot of things are settled, and then you get to meteorology, and it's just, nope, we barely know anything, and so
Yeah,
there's just
yeah,
always more stuff that we're going to be able to learn. I think it's really cool to be alive at this time.
yeah. No, same.
All right, we can take it back there to the dew point maps, I believe, is what you were getting ready to dive into.
Yes, for sure. Yeah, you could see just this being kind of this general late summer cold front feature. You see a pretty large eradication of dew points behind that boundary. A little bit more than recent days. It's pretty comparatively dry in the mid to upper 50s behind this, when we have 70s, even mid 70s, kind of east of the Appalachians. So this environment down here is going to be pretty juiced. We're getting in your mind, we're dealing with mid, even upper 70s dew points here with that much warmth and compressional heating. We might get some strong wind producing storms to form out this way. But then obviously we have this cold front here that's going to provide a lot of forcing for ascent and storm. So already I'm wondering, maybe if we have too much smoke or more smoke than modeled, I could see this area down here being the first one to potentially go and or bust, if you will. But I don't see this mode busting at all. We have very strong forcing along this front. We're going to get convection here. It's just a question of how much. So if we shift over to Cape, I'm guessing we're going to see quite a bit of Cape, especially in the lee of the Appalachians. And you do for this area. We're working our way in. Well, my color bar up on here, but probably at least over 3,500 here. So we can pull a sounding, and yeah, we also we have 4,500 on UCAPE here. I guess today's lesson though is a lesson on entrainment and just how much of this cape are we actually going to utilize. This shear is not great. Obviously, I think this is pretty good for severe gusts. Like you already have 25 knot surface flow, relatively swift storm motions. So I don't think we'd have too much of an issue getting severe gusts, but I'm not sure if we're going to use all this Cape profile. To do that, you're going to need a robust supercell with a strong mesocyclone. I'm not exactly sure we're going to be getting that down here at least. So when we see 4,500 Cape here, it might actually be more like 3,000 or 2,700 after accounting for these smaller, probably less severe storms.
What comes to my mind is I remember being taught by Skip Talbot back in the day that you really want that thick, fat cape, not so much a
Mhm.
taller, skinnier cape. And that was the first thing that came to my mind when you were showing that
True.
sounding.
Yeah, the sounding. You do have that tall, skinny cape, weak lapse rates here. Yeah, just generally not super great. I would call this fat cape, and I think in the right, it's fat and tall. But
It's
I
just
think
like me.
I wasn't going to go there. But if we had more shear, we could be using a lot more of this cape, but we definitely are not. And I think, Gabe, your rule of thumb there, I think that does work pretty good. But I think what's most interesting to me is we could pluck some soundings along this front. Might have slightly less cape, but we have more forcing there. 80 over 75. God help anyone who goes outside in that. That is air you can wear. Really good photograph if you like winds, right? Strong storm motion. These storms are going to be forming, moving very quickly. Any downbursts that they can produce are going to have some momentum behind them. One thing that's interesting is our LCLs are not particularly high. I noticed this. We weren't really warming up that much in this area. So while we do have the hodograph working for it for wind, I'm not exactly sure that we have the SQTs working for it. I'm going to use some more models and make sure that this is a correct assessment. But this almost looks like a sounding that you could get tornadoes from. Really strong low-level streamwise vorticity here, and then strong low-level cape, upwards of 200 for a near-surface phase parcel. So maybe we can look at probably our lower bound here. We'll look at the HRRR. A lot less cape out in kind of the east of the Appalachians region. Much taller LCLs here. We really mix out a lot of our dew points. Again, photographs are pretty bad. So I'm definitely starting to get the image here that if you're a chaser from the Virginias, probably these storms will not be very supercellular. Could they be and produce kind of this blue dot outbreak? Absolutely. I'm just thinking our tornado threat's going to be a little bit minimal here, as will hail threat as well. But up here, I think this is where most of my interest lies, up in kind of your region here, Gabe, eastern Ohio and western Pennsylvania and New York. This looks a little bit better for wind. We still have that strong low-level surface flow, and we've mixed out these dew points down to 70 or so. We have almost 20-degree spreads and a lot of cape above this. So if the HRRR solution is right, I would definitely not be surprised to see widespread, even at times significant severe wind in this general area, and perhaps a tornado or two.
Now, is the reason why you wouldn't expect to see much wind when you have that 80 over 75 TD spread because there's not a whole lot of opportunity for evaporative cooling?
Correct, exactly. And let me see, NAM is probably going to be even more egregious with this. Yeah, and not even that, but this is kind of backwards of what you want, in my opinion here. Lots of dry air loft. This is going to shrink the size of storms and really reduce the precipitation efficiency of these storms. And so when you have less precipitation produced, you have less precipitation to evaporate. And then you also have reduced time for that precip to evaporate because our cloud base is so low, we're going to remain saturated. So it's really interesting the differences that you're seeing here between NAM and HRRR. I'd obviously hedge somewhere in the middle where we have maybe some decently precip efficient storms that might be producing gusts occasionally, maybe clumping up and becoming supercells, maybe producing a wet tornado or two. But if you lean toward the NAM, you might actually struggle getting a lot of wind. But if you lean toward the HRRR, you're going to get a lot of wind.
Have you ever wanted to spend a full week chasing storms? We're opening up seats for another 2027 tour after our previous 2 rounds sold out almost immediately. You'll take part in daily forecast discussions, target selection, and the real-time decisions that shape every chase day. Seats are limited, and this tour is priced to make an unforgettable storm chasing experience more accessible. Click the link in the description below to reserve your seat before it sells out. Our favorite time of the evening, Cam vs. Cams. Let it ride.
Let's do it. So let's see if the HRRR, we'll go step by step, see if the HRRR ends up showing what we think could happen, given all these assumptions that we made about the atmosphere. And you can see it's actually pretty quick to form this leading line of convection. Definitely seems like there's probably more of a trigger than I was seeing here earlier. A lot of this looks like there's kind of a frontal boundary to this. So maybe if we looked harder on maybe an 850 millibar surface, you might be able to see something, maybe some enhanced prefrontal convergence, but I won't get too much in those weeds. HRRR is actually fairly bullish with these, which is interesting. Maybe I'll pluck a sounding earlier on in the day to see if we have the shear to support this, and it sure looks like we does. We do. We does. So there's obviously something I was missing here. I think I was looking a little bit too late and a little bit too far south for this. So I'm actually going to go backwards and see if it might be this early wave here, because we saw that those storms were forming in southern New York, eastern Pennsylvania around noon or so. So it might be that there's kind of this elevated frontal feature that kicks off these storms. And of course, our shear ahead of this little shortwave is pretty strong. I think I did this area a little bit of disservice. I could go back and show maybe some more representative earlier soundings if this solution were to come to fruition. And I think you'll see that they're a little bit more potent than the ones that I was showing earlier. Yeah, definitely. So sorry about that, guys. Glad I'm going back in and reanalyzing this. That's definitely something I missed just looking at your typical ingredients-based approach. So would not be surprising then to see maybe even enhanced tornado potential earlier, but farther north. Again, we were plucking these icky, weak shear soundings way down here. But if we got that low-level wave to pop off some maybe initially elevated storms, and then they cruise into a more surface-based environment, definitely would not be surprised to see a tornado kind of in this general area in the morning. But later on, you could see Old Faithful, that cold front starts to light up here, and pretty much looks about what we'd expect. Just some line segments with embedded supercells in them. Probably a better chance of tornadoes, again, to the north, where we have that better shear. And then further down the area via the Appalachians, you just get some popcorn convection that's very loosely organized. See how they are. Oh my God. I don't even know why I do this, guys.
Dude, the RRFS just wants everyone to die every single time.
I'm going to skip that one. We'll go to the updated version. Not as enthusiastic about that early wave. So this is kind of interesting. This is something that we need to watch. Maybe the HRRR is most enthusiastic about this. This does not look as enthusiastic. HRRR has pretty much, or FSV2 has almost exactly what we'd expect, with some more popcorn storms down south, but some more organized linear storms up north. Contrary to this model that shall not be named, it looks a little bit more tame. Go to the NSSL, fairly similar look. Maybe that early convection gets kind of strong over kind of the New York area before going out into the Great Abyss. And then, of course, you could see again some signal for some potential supercells and line embedded storms up north in New York. So definitely seems like the strongest signal for chase-worthy storms are for you folks in Albany right now, or Binghamton. Looks to be a fun day. And then we'll look at the NAM for our moisture-rich solution. I guess maybe not surprisingly, goes crazy with the lead stuff. Again, kind of has that elevated mid-level front kind of look to it. Storms are a lot less intense than the HRRR has, but maybe as they get with eastward extent, right off the coast might get kind of strong. I would imagine this kind of saps the buoyancy for these rear frontal storms too. But again, you get that signal for some supercells and line embedded rotation up here in the Albany area. So again, if you're an Albany chaser, I think I'd have my ears perked right about now.
And I'm actually glad, Cameron, that you were a little bit off at the beginning, because I think it gave all of our viewers an opportunity to see what it's like to build those checks and balances into your forecast. So that way you're constantly looking and seeing if everything actually lines up. Then that allows you to go back and course correct after the fact. So I think that was really helpful for us to see.
Cool. Appreciate that.
Last thing before we get going here, Cameron, could you please let folks know what should they be looking for if this day were to overperform? What's the strong signal that they would want to see?
Yeah, I'm looking at the most likely highest ceiling, given everything that I've seen here. And I think that most likely highest ceiling is somewhere in New York here, central New York. I think we have the least amount of uncertainty, right? We have a cold front coming through. We have the best environment generally. And so I think this is where I'd be targeting if I were in this general area. So I'll focus on this, and I think what I would want to see to have a best case scenario here is not this. Even if the NAM is showing this coming to fruition, I just think my forecaster intuition says if you wake up and all of eastern Pennsylvania, eastern New York is shrouded in this mid-level elevated convection, I am not exactly sure if this solution is going to come to fruition. We'll have to see, especially with these smoke concerns, and just the stability left behind by these showers might just be a little bit too much. So I'd almost be rooting for a RRFS V2 solution in which this complex maybe is not as intense as the other cams had. But obviously, I do want to say again, I don't think smoke is going to be a huge issue. We're going to get storms here. It's just what degree of prefrontal stuff do we have, and how many of these are actually going to be able to become supercells when they're embedded in a line.
Remember to check out those links in the description below, and then watch another video.